selection criteria. By default, if the user does not send it, it is star. Then you'll have limit. By default, if the user does not send it, it is 100. So when the user sends a selection criteria, what you end up doing here is in select, you'll just make it a separate string and just add selection criteria and move ahead. Similarly, for limit as well, you just go to the end of the string, add plus, and add whatever limit user wants to add. So if user wants to specify this, they can. If user wants to skip it, they can. You can also make limit equals none. At this point of time, you need to do two queries. If limit is none, you just have to run without this. You can write else this whole thing with the limit. There we go. So you can perform such simple operations, which make sure that whenever user wants to, or whenever you want to call select query from any other function in your code, you don't have to write the entire query here. Instead of writing the entire query, you just have to specify what is the selection criteria and what is the limit. If you don't specify selection criteria or limit, it will retrieve everything. If you specified whatever you have specified, that is what it will retrieve. So this is one way to write it. And most developers, most of us, when we work around in real life with this, we create our functions like this so that we have separate function for each process. This is what makes our repo.py class. So this is going to be what I used to call as repo or repository.py, which will have such a class, which will have such individual functions to perform those operations. So whenever a user reads, think about this, whenever you give your program to somebody else will go through your service layer of code. It'll be database dot, let's say, save, or database dot insert, whatever function you might want to create, of what are the key value pairs that you want to insert. Key will be the column name, value will be the value, and you take this and you insert it into the database. So any user or any programmer who sees your service layer will understand this, and they don't have to go through an entire query to understand what's happening. This makes it much, much easier. Similarly, if it's a search function or find function, just use db.search and just send the two things. That is selection criteria, what do you want to search, and the limit. Limit is optional, so you don't have to send it compulsorily. So all these sort of things will help make your programming much better, because you don't have to write complete queries again and again everywhere in the code. You just have to write the important parts of it. This is just one way to work around it that we need to know. And it's a very common way for us to use. But for our initial understanding, we're just going to execute a simple query. Let's just stick to this for now, for our simple purpose. So I'm just going to take self, comma, query. There we go. Now, once you want to execute, or the moment you want to execute, let's say, a particular query, here's what we're going to do. First thing is we're going to create a cursor. Cursor equals self.connection dot cursor. Once this cursor is created, you use cursor dot execute of whatever is the query. And once you've executed it, you take the result, cursor dot fetch all, then you close the cursor, and then you return the result. That's it. This is going to be your simplest execute query logic. That's pretty much it. We'll have our execute query logic in short like this. That's pretty much all we need to know. That's pretty much all we need to know to begin with that can perform this operation. Now, let's just run this to make sure it runs without any error first. It's only a class. Oh, one mistake. Let's fix these. All right, so no errors. This works as expected. Now let's create a couple of objects up next. I'm going to create connection from service or service connection equals. Let's create an object of it. And you might want to have some other connection like user authentication connection equals, let's say, another connection. So we've just created a couple of connections now, and let's see what happens. I'm just going to print ID of service connection, and I'm just going to print again ID of user authentication connection. Let's run this. You get to see they're of the same ID. This is the important part of what we're doing. This is what tells you that you have essentially made a single connection to make sure that you use your database very, very efficiently and it can connect and perform any operation you want. Now, we'll go ahead and try a couple of queries, but prior to that, if there are any questions still here, please feel free to ask. Please let me know if there are any questions. I'll take them up and then we'll move ahead. Right, so I assume there are no queries, so let's yeah, go ahead in that case and move along. Now, let's go on to the next step. I'm just going to use service connection dot execute query of select star from Pokemon limit 5. Now, as we did the previous query, we can do that as well. I think it's better if we change this query to the previous one that we just did. Let's try that as well. So whatever result it gives, we're just going to print this. Let's see what happens to do this to begin with. Now, oh, I may have, okay, there you go. One minor error from my end. There we go. We got 5 rows of data from the database. Now I'll just close this and open. For some reason, some functions are not detected properly. I'm not sure why. Okay. Again, I'm unsure why it's not detected, but for our purpose, yeah, let's not worry too much about it. Let's make another query that is called select query, where we take 2 values. One is selection criteria is star and limit is 100 to begin with, or there is no limit. Let's assume there is no limit at all. So selection criteria star in a string and there is no limit. Now, in this particular function, once you do these basic connections, you create a cursor, you execute a query, get the result, you return the result. Before that, you close the connection. One thing that you can see here is if in our particular case scenario, if at all, let's say limit is none, our query should not have that limit thing at all. So we're going to write if limit is none, I'm just going to write query equals select plus whatever selection criteria is there plus from again in our table name we're specifying here. I'm just going to take that same thing over here and then that's pretty much it. We don't have to do anything because limit is none, whole query will be executed. Else you can just specify query will be something like this. Now, instead of this complicated query, see how easy it seems to the eye when you look at it, when you read it. That's the whole point I want to make. Now let's make limit plus string of, remember, limit will be a number that we're sending, right? So we're going to have to convert it to a string of whatever limit value we send. Right. Now let's do the same now. I'm going to print user auth connection dot select query of, this time selection criteria is star. I'm going to leave it as it is, and limit you're going to end up. Now there's one little problem that you're going to face here, one minor problem that you're going to face here. You're going to have to send selection query even though default is star. You have to send it because you cannot keep the left part empty and send only the right part in Python functions. You cannot do that. And let's set limit as 5. Now take a look at this. If I click on this function, you see there's selection criteria and there's limit. It will say that selection criteria is star by default, limit is none by default. You can also specifically point out limit should be inked, like how we did in our previous functions. There's so many things you can do. But yeah, let's run this ahead. And you get to see the same result, same response. But take a look at how these functions are made. This helps you create a wrapper. Again, I'll tell you in another way. The whole point of this is that you create a wrapper around your database so that we don't have to execute queries in your code. You don't have to keep remembering, hey, I'm writing Python code right now, but I also have to figure out this complex query that I need to execute. So all these things will become way too easy to work around. So that's the whole point. Now, I hope this so far makes sense. I hope this gives us a good idea of how the basic idea or the basic logic of um, sorry, the basic idea or the basic logic of a singleton class works and how you can utilize it, access it, or so on. Anyway, with this whole idea, let's move on to the next case. Prior to moving on, again, just a query. If there are any questions or any queries still here, please feel free to let me know. If there are no queries, on the other hand, we can move ahead right away. So yeah, before we go ahead, I hope this so far makes sense. Please let me know with just a thumbs up if it's fine, that the whole idea of this makes sense and it's easy to work around. Or if you have any queries or if you'd like to see any specific code to be done on top of this with database connectivity, please let me know that as well. We can take a look at that also if required. Otherwise, we can try to look at and work around a couple of other things on top of Python as well. But shall we go ahead in that case, if it's fine? Or any response would absolutely help me out to know if you feel there's something specific that you'd like to know with SQL, because I know your expertise in SQL is quite good when it comes down to this. So if there's something specific that you would like to check in, we can do that. Or I'll just walk you through a few more packages. So any response would help me out.
I think you can just keep going through the examples you have.
All right, all right. Thanks for letting me know, James. Moving ahead from this, right now we have connected to the database with MySQL connector. Again, just like how we saw pandas and um, PyArrow and polars and so many other packages, this is not the only package to connect with databases. There's another package that will help you connect with SQL databases. That's called SQL Alchemy. This is a very well used library. A lot of us use this. A lot of really big programs I have seen work around this. You can basically see it says 97 million downloads a month. I did not know that it was that high, to be honest. But oh, 94 million, but minor change, but it's still quite a lot. So um, yeah. This is a really, really good library if you want to work around, um, let's say, MySQL or PostgreSQL or SQLite, any of this. So this is basically an ORM as well. So whenever you talk about ORM, when you want to work around it, it's gonna help you relate objects essentially. I'll show you with an image that helps us understand it better. Right. So here's the thing. The way you have taken a look at what we have done is the most basic understanding. This is the most basic understanding of how um, a database connectivity works. In reality, the way a database connectivity works will be even more complex than this, and that will require ORM. The idea of ORM is you will have a class for each table in Python. For example, think about this. If there's a class called if there's a table called employee, you already know what are the things that are what are the columns that are going to be there in employee table. You already know there's going to be ID, there's going to be name, there's going to be, let's say, phone number, there's going to be, let's say, again, the default example we learn when we learn SQL, there's going to be department, there's going to be a contact number and all these. So what you end up doing here is you're going to create a class called employee. And this class called employee will have the following variables: ID, name, phone number, department, and contact. And what you end up doing here is anytime you want to insert a row into employee, you're not going to insert all these values by yourself. Instead, you're going to create an object of this employee class. Let's call it as E1. And you're going to insert E1 into this employee table. This will make sure that all these key value pairs are accurate, they're correct, and you're not messing up the database by adding some wrong data here or there. This is the main purpose of ORM. This is a huge purpose of it. So you can see here, you'll have a class, let's say a C1, C2, C3, or domain class like this, and it connects to the database so you can directly store within it. That is something that SQL Alchemy provides, and it's yeah, there we go. ORM quick start. The moment we searched for it, we immediately got this. So yeah, you basically create classes like this by specifying what are the data types of, or what are the parameters of these classes. There'll be an ID. We specify that it's the primary key. There'll be a name. There'll be a full name. There'll be some addresses, all these things. And once you do this, you just need to create a object of this class user, which will help you insert elements. That's basically how we do it. It's a really easy way to keep track of these things so that you don't have to write them separately. So think about this. You create your code, you will remember it. If somebody else starts looking at your code 1 month later, if they have this class, they will know, hey, I just saw this class. I don't have to look at the database. I know ID is the primary key. I know these are the other things that we have. And all I need to do is create an object of this class, use the ORM framework that is Flask Alchemy, SQL Alchemy, and connect ahead. That's all. That's the whole idea. And yeah, just for our reference, for us to know, this is how you can go through this and how you can play around and work around with these sort of things, just so that you get to know. Anyway, let's move on to the next part of this. Right. So moving ahead. Now that we understood just the basics of it, I do understand that we can't go in depth within all of these in a short time. because let's face it, we just have a couple of hours pending at maximum in our case with the break as well. So we cannot go through a lot of things together, right? So I'm just going to share these things so that if you're interested in them, if you want to learn them ahead, you can go through and check them out, because these sort of things, again, to be a developer in Python and to go into certain categories, they help out quite a lot. They help out a lot, to be honest. Yeah. So I'll just take few things. So you can see anytime you want to perform select and join, um, the way you get to work around them is quite different, like how you work around. You will rather use these classes that you will use and parameters of the classes to perform everything. So we don't have to do things like this. If select star, you don't have to replace it with ID, comma, um, let's say type one or something like that. Instead, you're going to use something like this. You're just going to call a function called select. You're going to take a class. That class will connect to a particular database. In that class, you're going to specify with where any parameter that you need to add. This object relationship mapping will make sure that your coding will become much, much easier to connect to databases and work around things. So you can keep a track and check of code, check off your entire operators, entire things that you need to do in at a very high level to begin with. So yeah, if you want to look into this, if you want to check this out, SQL Alchemy is really, really beautiful. It's something that I would highly suggest anybody to look into and work around. Anyway, moving ahead from SQL Alchemy over to the next case. Let's go on to the next case scenario. Now, moving ahead from SQL databases, I just want to introduce you to connectivity of Python to other databases. Just as a simple question, how familiar are you when it comes down to NoSQL databases? That is on a scale of 1 to 5. You can specify whatever your familiarity is about it, because I only want to talk about one specific aspect of it, one very specific aspect of it, and that is where to use NoSQL databases in your real life usage and where to use SQL. So please let me know about this. This will help me understand your level so I can just walk through appropriately. So yeah, it could be any NoSQL database. It could be Cassandra. It could be um, Mongo. Any NoSQL database that would be absolutely fine. All right. That's absolutely fine. So yeah, SQL and Oracle are purely SQL databases. Absolutely fine. That's understandable. Now the new world is a lot of things are switching from SQL to NoSQL databases, and I'll specify why this is happening a lot. I do agree there's still a lot of purpose and a lot of usage in SQL databases because we have ACID compliant, we have a lot of research done in this, we have simple schema that we can create and we can store within them. There's a lot of things. NoSQL has no schema. You take away everything that SQL is made for, that gives you NoSQL. There is no schema. So you can store data in many formats. There's a particular database called Mongo, which helps you store data in JSON format. They particularly call it as BSON because it's called binary JSON, but you get the whole idea. You get to store data in JSON format, which means there can be a new key that can come up in a JSON one day. There can be a key in which a list can be there. In this list, another a set of dictionaries can be there. So you can see it's very, very um, expansive in its own way. Like, think about this. Let's say you're creating an application today. 2 months later, the client says, "Hey, I know there's this particular thing in database. I want to add one more thing." Modifying schema is a pain in SQL databases. You know that. You know that very well. If there is a possibility that request information might change, go for NoSQL databases. I'll give you one simple example. We recently worked on an application that required information from audio files. So there used to be audio files which go to databases. So we opted for Mongo database, which is a NoSQL database, because there are new things that might come up in audio that we don't know yet. We cannot come up with a schema immediately when we talk about it. For that purpose, what we essentially did is start with Mongo to begin with. And in Mongo, we added only a few keys like file name and something like sampling rate or sample rate, duration or length, file type or MIME type, whatever we might call it, and so on. But later on, over time, we got to realize, hey, when we are getting an audio, we are also getting information whether a male person speaks it or a female person speaks it, and the age of the person as well. We got all these information as well. So we're going to have to store that as additional keys. Modifying a schema in a database to store additional things is quite a pain. And for these purposes, we often use Mongo. And the other advantage in Mongo is if I want to store the entire audio file, I can store the entire audio file in its binary format as well within MongoDB. So whenever it comes down to storage of any kind of type, doesn't matter what type it is, we go for NoSQL databases like Mongo, Cassandra, and so on. And whenever you want to use any database in real life, please just look at this one thing: scalability. Any database you want to use within Python in future, will it be scalable or not? If it's going to be scalable, how can you scale it? Like for example, within SQL, you can access additional indexes to make search fast. We know about this, right? So you can add additional indexes to make sure that your search will be fast, so that there's not just one primary key that will be indexed upon. So there are a lot of different things that we can do. You can divide your database into two different servers. There's so many things that we can do for reference. So yeah, just something I wanted to point out as to where and why you can opt for the SQL databases that we have connected with. For instance, MySQL using SQL Alchemy, for instance. And similarly, you can also opt for a NoSQL database if you're planning to store files and so on. So just as a hint, if you want to look into different kind of databases and just learn what other kinds of databases are there, I'm just going to share two specific database names for your reference. One is called MongoDB. The other is called Pinecone DB. The purpose of them are very different. We cannot use SQL for this purpose, and we cannot use this for SQL's purpose. Each one has its own purpose. So if you just want to know different kinds of databases and you're aware, like, okay, I now know what kind of database I can actually use in what kind of purpose, you can, of course, take a look at this. This might be quite helpful if you are into thinking of learning new databases for your Python applications in the future or so on. Just one thing I wanted to share across. All right. So with this done, the next step of ours is to learn how to scrape web data. So the next thing we're going to learn is something called Selenium. This is a beautiful thing to do web automation. A lot of people use this. You can do a lot of web application automation for many purposes. So I'm just going to walk you through this. Um, After the break, we'll start looking into it. So yeah, let's have our break in the afternoon session as we do. Let's connect back in 15 minutes and we'll get started with that. And yeah, Jenny, since you have joined now, just as a heads up to us, I will be walking through the PDF specific libraries that have been requested as well, possibly after the break, along with Selenium. So we can take a look at those as well. So just to know, we will be covering those up to an extent.
Okay, thank you.
Right, thank you. So thanks everyone. We'll catch up after the break. Have a good cup of coffee or something. Thanks.